Donc, je voudrais vous introduire donc Alfredo, qui nous vient de Google. Il travaille en Italie et il a plusieurs postes, en fait, plusieurs rôles. Donc, il s'occupe beaucoup des GDG, donc on le connaît très bien. Et accessoirement, il s'amuse aussi pas mal avec Android. Et donc, il avait envie de nous parler un peu aujourd'hui de Conversational Powered. Donc, cette session, elle sera en anglais, hein, vous avez compris, je pense. Donc, nous n'avons pas de service de traduction. Peut-être vous regarderez, si vous voulez, la vidéo YouTube après avec les sous-titres.
I can also speak Italian if you want, but I think it's worse than English. Okay.
Mais bon, bref, je vais pas passer plus de temps. Autant laisser Alfredo continuer directement. Et puis, je vous retrouve tout à l'heure pour la prochaine session. Merci. Bon, on applaudit Alfredo pour.
So, as Jean-François said, my name is Alfredo Morresi. I work in Google. I'm in the developer relations team. So my job is basically present Google technologies during conferences, organize conferences, support technical communities in Italy, France, Spain, and a variety of other countries in Europe. My passion are, doing community stuff. Before joining Google, I was an Android developer, so I still continue to enjoy writing code time to time. Winter is coming, and so my other passion is snowboarding, and I love tiramisu. So, very quick introduction about me. If you want to reach me, those are my addresses, my email address, and my Twitter account. So we are talking, today we will talk about how to add conversational power to an Android application. And basically, when you want to have a conversation with someone or something, in our case, you need three basic skills. You need to be able to listen, to listen for a message, to understand the message, and also to speak, to produce a new message. So through the presentation, we will see how to add these three different skills to our Android application. Question, how many Android developers are in the room? Raise your hand, please. Okay, so I won't introduce like Android basic concept. We'll go straight to the code. But if anything is not clear, please let me know. Because we are here really to share and to understand, not to just to watch to a screen and say, oh, okay, cool, but maybe later at home I will try to understand what is on the screen. So let's start with a easy, I would say, part. Speak. Add the speaking ability to your application. Incredibly, the text-to-speech, so the possibility to transform a piece of text to a voice, was introduced in 2009, so more than 7 years ago in Android, and it has been supported since API number 4, so Android 1.6. There is an interesting blog post introducing the text-to-speech functionality, and as you can see, it's dated very, very far in the past. So whenever you want to do text-to-speech on Android, there is a class called text-to-speech. Let's see how to check for it, how to configure it, and how to use it. So first, you need to check, like for a lot of other capabilities on your device, if a text-to-speech service is available. And in order to do that, you create an intent. You set a particular system action. As you can see, the action is text-to-speech.engine.action check TTS data, and you start an activity for result. So in the background, the system will check for you about several things and will return something in the onActivity result. OnActivity result because you started with set activity for result. I know that today there are several other ways to check for services in the system. I would say even more elegant than start activity for result and onActivity result. But remember, we were in 2009, so very early in the Android world. So don't complain too much about this kind of syntax. So you check the request code, the one that you basically used in the intent you created, and if this is check voice data pass, it means that you are okay to go. So the text-to-speech engine is installed, several languages are supported already, and you can use it out of the box. You don't need to do anything else. Otherwise, what you can do, you can set another particular system intent in order to open the text-to-speech setting activity. We will see this activity later, and it's one of the system activity the system preference activity you can reach through the system menu. So this way you can say to the user, hey, I miss this component or this part, please configure your system in order to enable text-to-speech. It has to be manual action, so every time then the user come back to your app, you need to recheck, but again, it was 2009, so a little bit far in the past. Once you have everything in place, you can start the text-to-speech engine with a very, very simple call. You create a new text-to-speech object, and because the initialization is asynchronous, you need to connect a listener to the object. And this listener has just one method on init that is called when the initialization of the text-to-speech engine finishes. So you say, OK, fire the initialization, and let's wait for something to happen. If what happened as a status with the value text-to-speech success, again, you have done. Text-to-speech is ready to be used. Otherwise, you need to check for error condition and blah, blah, blah. And in order to use it, you need to check, for example, what are the available languages. Text-to-speech, like all the other text-to-speech, relies on a set of sounds for every language. So by default, you have installed the language pack of the system, plus generally English. If you want, you can access to a variety of different languages, more than 80, so 80, but clearly in the system there aren't all the language boundaries loaded and unloaded, because it would have been a lot of space. So you can check for the available languages in order to avoid re-downloading those samples, or say, OK, if I have this language, I can work without problem. Otherwise, I need to ask to the user to download this particular language pack. How to check? Very easy. There is a method, is language available, and you put the local of the language. Very important discussion here. Because it's a text-to-speech, we need to talk a little bit about localization and internationalization rule. So every language is defined by technically 3, but in this case 2 attributes. This one is the flavor, and this one is the language. So, for example, for France, you can have France like the flavor and France as the language. For English instead, you can have American English, UK English, Canadian English, and other kind of English. And so the way you define them is that way. So there is 2 letters for the flavor and 2 letters for the country. Clearly, the best situation is to have both the language pack for both the flavor and the country. But if you have the one for the country, you are already done. OK, I can speak English. Maybe it's not your Canadian English that you love and you like, but more or less we are still English. Instead, if you have both of them, you are done, and you can have a proper language. There aren't so many languages with one language and several flavors. It's English, it's Italian, for example. There is the Italian and Switzerland Italian. I didn't know about that, but it's true. And so I would say, in order to check for your language, try to shot for the best, like flavor and country. But at the end, if you have the country, unless it's incredibly important to have the flavor loaded in your system, just go for the country and don't bother the user with, hey, could you download additional stuff? Because it's another step you introduce in the user flow, and this is generally a bad practice. So you check, you call this method. The result can have these, values. Language available is like you have done. Great. Country available. Only the country is available, not the specific flavor you have asked. Country var available is like country and the flavor is available. Missing data is, I'm able to speak this language, but I don't have the specific language pack downloaded in the system. Lang not supported is like, sorry, it's not in my 80 languages I'm able to speak. So here you can, lang missing data, you can download the additional languages, asking to the user. Here, lang not supported, no way, you can do nothing, you cannot speak this language. One of these 3, it's OK if you want to do text-to-speech, OK? Everything clear? Yes, good. Yes, sir. What's the difference between the first available and the country Those are, okay, the question was what's the difference between the first one, long available, and the other one. If you see, some of them are deprecated and some of them have been introduced later. So basically now you check long available, and you have done. In the past, you needed to check country, country var, and so on. Okay, but again, in the documentation, you will see all the values, because as I told you, it was a very, very old API, so I will relog in. Okay. Oops. Okay, so you set a language. If you don't set a language, the text-to-speech will start with a local language installed on the device. So you may be okay with that, or you want to change it, or you want to enforce a particular language. It's totally up to you. And again, the result to set a language are the same values that we have seen before, so nothing new now. Finally, you can speech, okay, or you can command your device to speech. How to do that? There is a method, speak, very easy, where you put first parameter is the sentence you want to say. It's like in a plain language that you have selected. Clearly, if you select English as a language and French as a sentence, you may have something weird pronounced, like Italian and English. So you need to match the language that you have selected and the sentence you want to pronounce. You can then you add a parameter that controls the way you put the sentence in the queue, in the text-to-speech queue. Because it's an asynchronous service and is shared among the rest of the system, you can have two ways. You can say, okay, this sentence add to the current queue, so maybe the text-to-speech is already speaking, this sentence will be put at the end of the queue. Otherwise, you can use queue flush, and so you say, everything I created, throw on the bin and just say this particular word. This is very useful, for example, if you are having a conversation with your user, but then an alarm comes or something that have a priority, you can use queue flush, and your sentence will cancel the current queue and be spoken by the system in the exact moment you submit this sentence. Okay? And then there are other two parameters that we will see later. Don't worry for now. So very easy. Speak, sentence, and the way you want to put this sentence on the queue. Okay? We will see an example in one moment. Everything clear? Good. Okay, maybe you want to check how this speaking process is going. Like it has started, it has finished, it were some errors. In order to do that, you can register a particular listener called the uterance progress listener that notify you when a sentence is, when the system starts to speak your sentence, when it's done, and if you had some errors on the way. How to, because you can put different sentences in the queue, we said. How to check is finished what? The first one, the second one, the last one. You check, you create a connection between what you put in the queue and this listener through the uterance ID. So every time you submit a sentence, speak, the last parameter can be a uterance ID. It's randomly generated, so it's totally up to you to generate it. It's a string. And thanks to that, you will have this parameter during the different methods, in the different methods of the listener. So you can say, okay, this sentence was the first one, this was the second one, and so on. So you can connect the events with a particular sentence, just adding this parameter here. And finally, to be a good Android citizen, you should destroy the service that you created in your application, and this is generally done on destroy of the activity or the application or whatever you want, but please remember to initialize the text-to-speech and then destroy it when you are not using it. There are also other methods like to pause, to play, to do other stuff. But this is, very easy introduction to text-to-speech. Again, you can set additional parameter when you speak. For example, here, you can set the stream. When you set the volume of your phone, you may have noticed that you have 3 different streams, like alarm, like general media music, and it's the phone ring volume level. Those are streams. So you can say, okay, this particular sentence, instead of going through the usual media stream, that is, again, the default one, would go through the alarm, or would go through I don't know, another stream that you even may customize. It's very advanced usage, so we don't care now, but you should know there is the possibility. Also because you can synthesize to file instead to the audio stream. You can synthesize a sound to a file. So for example, you can create automatically a lot of sentences, a lot of stuff, and you can put in on a file. Maybe you need that. And you can also add vocal samples to your engine. So you say, for this sentence, this particular sentence, instead of synthesize the sound, use this sample. You can ask your user, hey, can you pronounce welcome? I pronounce welcome, I register that, and then I associate your welcome voice with a welcome word. So every time you say speak and you put the word welcome as a parameter, instead of the text-to-speech, my voice is played. And you can customize and do this. Clearly, if you put welcome, my name is Alfredo, okay, the text-to-speech will say welcome, my name is Alfredo. It's not able to say, hey, welcome was registered, so welcome, I will use the user voice, and for the rest, I will use the normal voice, the text-to-speech voice. But it's already interesting what you can do with just these two parameters. You can also add I don't know, customize sound to words. If you want to do emoji, for example, and you want to add sounds that basically vocally represent some emojis, you can do this using the add speech method. So the possibilities are really, really interesting. Okay, let's see a quick live demo of the app. You know, live demo are always discouraged during presentation, but I love to do that. So, okay, this is my device. And this is Android Studio. So in this basic project, I create a very simple, you know, main activity. Oops, allow me to choose between these three skills. And then there is one activity for each skill that I want to use. So in this case, we are to the speak activity. And as you can see, in the onCreate, you know, basic Android stuff, put the button on click listener. And here, check for TTS capabilities, the first slide of code we have seen. I go to onActivity result. If everything is good, I go to init text-to-speech. Otherwise, I call the text-to-speech setting system activity. Okay? This one, as I told you, it's another intent with a system action. This one, instead, is where I create that text-to-speech object and I check in the listener for the success. In case I wasn't, this is very important, successful, I simply shut down everything because this is a demo app. In theory, I can read the error, try to ask user why it's not working, and so on. Once if the initializations go well, I also set the progress, utrans progress listener. And as you can see here, the actions are very, very easy. I log something on the logger, something directly on the screen, and on error, I also log something. This is the set language, very easy. Is language available? I check for the different return values, nothing new, what I said in the slides. And if there is missing data or not supported, I simply also in this case quit. I would say missing data, I could have opened the system preference activity, but again, it's just a demo app. Finally, I set the language, and I'm ready to go. With Speak, I create a utrans ID from the beginning of the sentence, like the first 8 chars of the sentence, and then I add to the queue, and I use a utrans ID. And the utrans ID is useful for showing some other parameter. Done. So it's 200 more or less lines of code, and let's see how it performs. Okay, it's building everything. Are you able to see the device? Yes. Good. Okay, let's install the APK. No, because I'm using my personal device, I don't have install run enabled, and so it's a little bit slower, but don't worry. It's a very slow. Okay, we are in. Okay, let's start with listen, as I said. From the log, you can see that everything went well. I set the local to NGB, and I can, sorry, it's not listen, it's speak. Sorry. Okay, let's speak. So, TTS available, initialized, so I can use it. I can say, hi, everyone.
Hi, everyone.
Done. As you can see here, if I repeat,
hi, everyone.
You have a small delay between adding the sentence and the sentence complete. So I'm really controlling the flow. And my event, like completed, is called when the speech action is completed, not when I launch it. I can set the English language, and because I was using the default language of my phone, in this case English, now I'm setting the English sentence. As you can see, setting new language, and only variant is available.
This is a sentence in English.
I can also set the language in French, and you will see that now more time will be required to pronounce this sentence because the system has to load the French language samples and initialize them and then finally speak.
Il s'agit d'une phrase en français.
Okay, done. So whatever you want to put here, you can. And now your application can speak to the user. Good? Questions? Please.
Is it possible using the utterance listener to have updates on the voice flow? Like if I want to have a circle animating
No.
with the voice
No,
flow?
not in this case. Because the utterance listener only give you on start, on done, and on error. So there aren't other methods to update you on the progress. There is in the speech recognition, but not in the text-to-speech. Okay, let's have another question. We should have time.
Is there a way to pause the service? I mean, for instance, if the activity is stopped or paused, do you have a way to pause the text-to-speech?
Yes, you can cancel what has been pronounced. Sorry, what is pronounced. So
yeah, I guess if you send multiple sentences, and then you're going to have multiple results, but asynchronous. So if the activity is paused, and after that you received some result, then how do you manage this?
Stop.
Oh, okay, so but it will flush the queue.
Yes, okay. Stop everything. Right. So you can flush the queue with a new sentence. You can even do the trick like flush the queue with an empty sentence, but no, you have stopped, so you stop and you have done.
Okay, all right, thank you.
Okay, and as you can see, here I can also queue.
Il s'agit d'une phrase en français. Il s'agit d'une phrase en français. Il s'agit d'une phrase en français.
Do you see the listener that is being called at the end of every single sentence? And I queue 4 of them. Okay, let's move to another skill we want to add to our application, and it's the ability to listen. So from something that I say, the application is able to write down a text, to recognize my voice. Again, this feature has been introduced a long time ago in Android 2.2. So again, it was here since a lot. It has been here since a lot, and the class to use is speech recognizer. It's pretty much everything you need to know. Again, it's a service, so you need to check if the service is present, and this is the code that you generally use to check if a service is present. You call the get package manager, a particular system intent, and if activity size is 0, you have issues because speech recognizer is not present. Otherwise, if it's not 0, so greater than 0, you may have one or more services in order to do speech recognize. Because one or more? Because you have the system one, but you may install application or components that add additional speech recognition services. So you are not limited to the only one present in the system. You can even create your own, or you can even customize one of the other one of the other speech recognition services that exist for Android. So it's totally up to you. So in this case, you have several ways to use speech recognition. Let's go for the easiest one, like open a system pop-up that asks you to pronounce a sentence, okay? And then let's see after that how we can go deeper and more customized. So very easy, you fire a system intent called action recognize speech, and you can put several extras in the intent, and the extras are the configuration you want to have for your speech recognition task. So first, you need to use the language model. One extra is the language model. So you can do like, when you call Google Now, for example, you can do a web query or a global full research, like a very conversational research. This one, model web search, is used to optimize the recognition model to very short sentences. This one, instead, freeform, is optimized for recognizing general speech, okay, general talking. I would say always use this model free model unless you have very specific needs. And also remember that it was Android 2.2, so really at the beginning of the platform, so I've never seen this model web search used. Just put in the API, maybe for future usage, but no future usage has come over time. But in any case, it's super optimized for small queries, small sentences. So you put the language model freeform. You also can put an extra prompt to tell the user, because he will see the mic and say, okay, the mic for what? Okay, tell me something, give me your mood, what's the weather outside. So you can specify a prompt, a text to prompt to the user. And you can also specify the maximum number of recognition results you want to have with different scores. So you may have several possibilities to go through instead of having just one possibility, and maybe it's not the most correct one. You should also put the language for the recognition, like before. If you put nothing, the system language will be used. Otherwise, you can force a recognition in a particular language. And this was absolutely useful in the past when Google wasn't able to support, multiple language at once. Now that you're able to support multiple languages, Google is able to support multiple recognition of multiple languages. This parameter has a sense to optimize, but you can even try to omit it. But my suggestion is, let's try to put it if you know, because you make the job of the speech recognition service easier. And this is a workaround for a Google search update that it was in the past. So you need to add this one. It was, again, in the past. Now it's not like that. But in the unlucky situation, you met a very old device, you also need to specify this particular extra non-documented key. And finally, you start activity for result with this result prompt, request prompt that you customize. If in the onActivity result, if the result code is OK, you can extract the sentences recognized by the intent, return in the onActivity result, the data intent. You can extract the sentences using a getString array with this particular key, and you can extract the score, the confidence of the recognition. So it's a value between -1, like I really don't know what is that, to +1, I'm absolutely sure this is what the user has pronounced, and a lot of other values in the middle. And so you can check for every sentence what's the confidence score for the recognition. It's pretty much is a concept widely used in the machine learning world, the confidence. And it's a float array. And then you can cycle through all the sentences in order to get them. In this case, show them, check for the score. If you want to do a very, very quick recognition, or you can limit the sentences to max number of sentences to 1, so you will get only one sentence, the most probable one, and you get the sentence with this simple get here on the array list. Okay? Everything clear? Perfect. Then we will see it in action later. Let's see that we want to do something more than the simple system prompt. Like I really want to have a real conversation. So I talk, I come back, I talk, and so on. So how can we do that? We need to change a little bit the parameters of the speech recognition service. First, we need to create our own speech recognizer instance, okay? With the create speech recognizer. You cannot just use a new, it's enforced to use this builder method. Then we need to set a listener for the several events that can happen during a speech recognition activity. Several, why? Because there are really a lot of them. Like, I'm ready for speech. Like, okay, everything has been initialized, I'm ready to listen to the user. The user has just started to speech. RMS is like the volume, so the volume of the voice has changed over time, and this is to what you have asked. Like here, you can check the volume. I received not the whole sentence, so the user is still talking, but in the meantime, I give you some part of the sentence. And this is, when you say, OK, Google, and you start talking, you see that your sentence is built a little bit word by word, and not like wait, 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 and then the huge long sentence will appear. So you can do buffer receive, end of speech, like, OK, the user has stopped talking. On error, on result, this is very important, is where the final result is sent. On partial result, again, partial results of the recognition action. And on event, it's like general other events. So once you assign the listener, you can start a speech recognition activity using the start listening call. Okay? And you use the intent we just created like before. So you put the language, you put the extra results, you put the prompt, whatever you want. So the intent is the same. It only changes the way you call the listener. Through an intent to have the system default activity, to start listening to have your own UI. In this case, nothing is shown on the user UI. You have to take care about everything, okay? And this is very important because you can customize here the speech experience of your user. On result, this is one of the methods of the listener. You have a bundle, and it's very similar to what we have seen before, only the name of the keys change, and you extract the string array using result recognition, you extract the scores using confidence score, and again, you can cycle through the sentences in order to identify what is the most probable sentence pronounced by the user, or again, you can just get the first one and, hopefully it's the right one, and you can hope it's the right one. On error, there are a variety of errors, like no match, speech timeout, a lot of other stuff. One important thing to do, because this is, I would say, not the system default experience, you have to take care about stop listening on the on pause and destroy the speech recognition service on the on destroy. Otherwise, you may have the user on another activity, on another part of your app or the system, and the speech recognition is still going on. Okay, seems like a cool stuff, like, hey, I can spy the user from outside my activity. No, because at the end, after a little bit of time, the user say nothing, the activity will, the speech recognition activity will stop by itself, probably to prevent this kind of stuff. So, some of final remarks on this part. All the methods that we have seen have to be invoked from the main application thread. Generally, till API 22, all the recognition is done. Sorry, all the recognition is done in the cloud, or if you are offline, it happens also offline. So you have this great capability for free, like speech recognition offline. But you cannot choose. API 22 ongoing, you can force offline speech recognition. This is very important if you want to have an hot word or, I don't know, something that you want to use to wake up your application or to wake up your conversational features. So you pronounce this hot word, you do all the you continuously listening to what the user says in your app, and you recognize it offline, so not big usage of resources. As soon as the user pronounces hot word, okay, you switch to online recognition, so you have a way more, defined recognition, and you need to put record audio permission on your app. And if you want to do online, also the internet access permission. Okay, let's see also in this case a quick... good. So, let's go back. Let's go to listen. Okay, we can start with the system prompt. Hey, good morning. Here it is. It is a wonderful day in Nantes. Boom! Wow. Good. I can set also, if I try, now the language is English, as you can see here. Okay, I try to say something in Italian. Ciao, mi chiamo Alfredo. As you can see, the result is very bad. So, I can set Italian as a language and retry. Ciao, mi chiamo Alfredo. Okay, it works. So setting the language, as I told you, it's very important to improve the recognition. And you can see here the different scores. And I think it's a kind of a bug that I've seen. You have the score just for the first result and 0 for all the other results. But okay. In this case, it was very, very, very probable. 97% is like very good recognition. So I can set English, and now I can switch to hands-free. So no system intent. Everything is managed by my application. Good morning. Okay. No system prompt, just the blip. The blip is something that they have, it has been introduced very recently, but in the past it was like no UI signal, no UI feedback on what I'm saying, only like, yes, it's continuing to recognize. Only like you have to take care of everything, and it's continuing to recognize. Hello? Okay, not much found quitting because it was a little bit of silent. Hello, how do you do? I'm fine, thank you. What's the color of the light? Okay. Good. Okay, as you can see, you can already try to figure out how to conversate with your app. We are able to listen, we are able to speak. So now, the last part is missing, and it's the understanding of the message. So how to understand a message that the user says? So generally, you apply the natural language processing algorithm. So natural language NLP called is a kind of is a field of the computer science that create understanding of sentences. Generally, you have a sentence like that, and the NLP classifies every single word, relationships with words, create a graph of the relationship, and a lot of other stuff. Okay, you can do it by your own. You may study a lot of time. You may, try several libraries that are outside here, or in the serverless age of humanity, we can also use a service to do that for us. I choose the API.ai because it has been acquired by Google recently. And so, in the API.ai, you have, again, the machine learning as a service in terms of speech recognition and action and so on. So, very quick concept regarding the API.ai. You need to create, to do everything, you need to create an agent. The agent is like your application. Inside the agent, you put your words, your parameters, your attributes. The machine learning is trained using all the different intent you put in the agent. So the agent is, I would say, the application, your single application. I create an agent for this application. I can use the same agent for another app or create another agent for another scope. It's totally up to you. Then inside the agent, you need to configure entities. The entities are a mapping between what the user says and the concept with a meaning, like turn on the light. Light is an entity because, okay, I don't know, I'm in Rome or I live in Milan. Milan is another entity because it's, it has a meaning and specifies something that I say. You have intent. Intent is very similar to Android. They map what the user says with some particular actions that you want to take. So basically assign the meaning of the sentence based also on the entities and the other stuff. And actions clearly are what you want to do. So turn on the light. Okay, the light is an entity. Turn on is a verb. Then, okay, turn on is a verb, and through actions you say, okay, if the user say turn on the light or something similar, I want to have this action light.on or turn the light on, whatever you want. So despite what user says, at the end you have always the same action. This is the way you can perform natural language processing in a very, very easy way. You define a bunch of sentences that the user can say, connect entities, and at the end you have an action that is the same despite the several ways user can express a will, a concept. And then there is also a context that have a lot of information that can help better understanding your conversation. So there is an Android SDK to use the API.ai, otherwise it's everything REST calls, so you can use it in any language you want, and it's very, very easy. But for the sake of this demo, we will use the Android SDK. The Android SDK has two potential usage. First one, let's have API.ai do everything for you, from the speech recognition to the assignment of the meaning of the sentence. So you don't need to care about text-to-speech and stuff like that. The other part is like, give me a sentence, a text, and I will give you the final meaning, okay? Again, we went through the do for me everything that you want in this demo, but it's very, very easy to also say, okay, I will use my own speech recognition, my own speech routine, and then I will simply pass to the service the final sentence I want to assign a meaning to. So you need to initiate the API.ai service. There is a configuration, the API key to use, supported languages, like there are 5 or 6 supported languages right now, French included. In this case, I use English. And here I specify that I want to use the Android system speech recognizer, so the one that you have seen before. There is another speech recognizer created by API.ai. It's called Speak to It. Or if you want, you can use other speech recognizer services, as I told you before. They are pluggable in the system. Then again, there is a listener to configure, and if you see it, it's very, very similar to our speech recognition listener on result, on error, on audio level, on listening started, cancelled, and finished. So very, very easy. In fact, if you look at the code, there is more or less a one-on-one mapping between the speech recognition listener and this API.ai listener. And you get the AI service through this call, and then you set the listener. And whenever you want to start listening, you simply do start listening. On result, you need to check for, I don't know, empty result, because in this case you can also have a problem with the network or other stuff you need to check. And if everything is done in the right way, you have a get resolved query, is the query pronounced by the user, and get action, so the final action you want to do. And then there are also parameters for this action, like, I don't know, I want to order a pizza in my house. And so pizza is a parameter, so order something, it will be the action, pizza is a parameter, and in my house is another parameter. So based on these 3 pieces of information, you can process a user input. Clearly, you can check for errors, And okay, yeah. Instead, if you don't want to use the speech recognition routine of the AI, API.ai, and you already have your sentence, because maybe you are in a chat service, so you don't want to interact with voice, you simply create a configuration. You create a AI data service, and you pass, you set the query, like the message you want to recognize, and you call the request method. So the request go online, send the sentences to the service based on your agent, blah, 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 and give you back a result. Clearly, these tasks here have to be performed in a background separate thread. Otherwise, you will block the UI. So we are at the end. Let's see the final demo. I can go back. And I can finally converse. Oh, wow. Okay. So a very two simple button. An advertising to skip. Good morning.
Sorry, but I don't know how to execute the action you asked. Any further request?
Okay, in this particular case, you have seen that I received the action small talk greetings because I said good morning, but I didn't configure my own app to, reply to the good morning. Okay, but you can, you see, good morning, and already have an action here. I restart conversation again. Can you turn on the light, please?
Done. How can I help again?
I don't know.
Say again, please.
It's very cool here.
No way I know how to do it. How can I help again?
It's very cold here.
Sorry, but I don't know how to execute the action you asked. How can I help again?
Okay, I'm not super good in conversating, but basically I configured this Bluetooth light bulb to be powered on off by the conversation. So let's see. Can you turn the light off?
Done. Any further request?
Light on.
Done. Any further request?
Could you please turn on the light?
Executed. Any further request?
Okay, as you can see, I can say turn on the light, light on, could you please, blah, 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 and everything is managed by my own. And I can also add fancy activities like, hey, there is a fire.
Sorry, but I don't know how to execute the action you asked. What's my next task?
This is true. Sorry, this is true. Let's create an action for the fire. Okay, so I go to the API.ai console, this one. I will create a new intent. Allora, here it will say what user is just saying. We are on fire. Enter action name, it's lights alarm. Okay, I save it. I can add entities, whatever I want, and I can also say alarm or maybe there is fire in this house, or whatever you want. You can continue adding sentences, and the machine learning algorithm, the more you add, the more will become good in recognizing this particular stuff. You can even try here what you have done so far. So I save. Okay. If I say light on, you will see the intent and the JSON reply with the action or whatever. And in this case, I just added this intent. If I go back to my application, you remember when I said there is a fire? the application wasn't able to do nothing, but now there is a fire.
No way I know how to do it. How can I help again?
It's important. I've already created an intent. Yeah, my fault, sorry. Test intent was absolutely the same. So I need to remove it. And now my new intent will be used. So without changing the app, just there is a fire.
Executed. What's my next task?
Okay. And so the alarm pop up. Okay, I finished. Thank you for the demo. And if you have a question, it's the moment to ask. Probably we have time for one demo. Yes.
So now I have two questions now.
Yeah.
The first one is about this API. Is this keeping the context of the previous sentence? For example, if I...
It depends on you. You can configure context and say, from this sentence, put this value in the context. So if the user at the beginning of the conversation say, hey, I'm Alfredo, you can have the entity name Alfredo stored through the following conversations. So at the end of the conversation, your agent can say, goodbye, Alfredo, because I told to the agent my name at the beginning of the conversation,
Yes,
but
I
it's totally up to
understand.
you.
But, for example, if I turn on the light, and then I say, now turn it off, is it understand that previously I was talking
You can
about the
save,
light?
for example, the location in the context, the location of the previous light that was turned on. And so at the next turn it off now, you have already the reference to the previous light. So it's totally up to you to model your agent. By default, it doesn't store the history of the conversation. You should do by your own. So you can use the context or any other method that you want.
Okay, and the second question is, there is an elegant way to check what languages are supported in the speech recognizer, because you told before that there are gonna be third-party speech recognizers.
Yeah. It depends on the speech engine. So some speech engines are configured to tell you what they are able to recognize, others are not configured. So it's totally up to the speech engine.
Okay, so we need to initialize all the speech engines and then ask every of that.
Yeah, generally you use one speech engine. You don't use a lot of them. Also because it's very, I would say, it's difficult that the user has more speech engines on the device. Generally, it only has the default one, and probably you are adding a new one through your app. So basically, you know that your speech engine is present on the system.
Okay, thanks.
Is it possible to recognize the emotion in the voice, like the user is in panic mode?
Not through API.ai, but because you have the sentence, you can then use any other service that you want to query for the sentiment of what the user has said. But right now, it's not possible in API.ai.
Okay.
Any other question?
Do you think at some point we won't have to tell the APIs, those APIs, which language is going to be used? Just let the API guess the language?
Okay, API guessing the language? No, not API.ai. When you create an agent, you have also to specify, this is VoiceHouse is my agent. Okay, and I specify the language. And in this particular case, I cannot change it anymore. Okay? But if you want, you can have several agents for several languages. It's also important because, for example, when you have an action, you can also set a reply returned by the agent or a set of potential replies. So you have more conversation ongoing with your users.
Okay, thank you.
Yep. Okay, I'm outside. If you have other questions, please welcome.
There is a QR code if you want for feedbacks.
Ah, yes, and there is a QR code, so if you can provide me feedback, because it's the first time I present this session, so I'm super, super interested in your feedback about it, what you like, what you didn't like, and how can improve over time. Okay, thank you.